I now want to move on to my next type of factoring, which is factoring trinomials. And we're going to start with looking at trinomials of this form, x squared plus bx plus c. So the coefficient of x squared is equal to 1. The idea of this is we want to write it of this form, x plus p times x plus q. And what we need is that p plus q is equal to b, my coefficient in front of x, and p times q is equal to c, this number, the constant number at the end. And when we do this, we're going to start by thinking of everything that multiplies to give us c and figure out which one of those adds to give us b. So let's start to look at this. The first example says x squared plus 8x plus 12. So I need to think of everything that multiplies to give me 12. Well, I know 1 and 12. I know 2 and 6. And I know 3 and 4. And that's everything that multiplies to give us 12. On the other hand, we need it to add to give us the 8 in front of the x. 1 plus 12 is 13. 2 plus 6 is 8, and 3 plus 4 is 7. So we found the appropriate value here, 2 and 6. So our factored form, x plus 2, x plus 6. And you can absolutely check this answer by foiling it out. Our first terms would be x times x, that's x squared. The outside would be x times 6, or 6x. The inside, 2 times x is 2x. And the last two, 2 times 6 is 12. And once we simplify this by adding like terms, 6x plus 2x is 8x plus 12. And so we get it back to where we started, which is good. So this is correct. Let's do some more examples. The next example, x squared minus 7x minus 18. So once again, I need to find things that multiply to give us the last term, the term without any x's, the minus 18. Well, this can be done by negative 1 times 18 or 1 times minus 18. It could be done by negative 2 times 9 or 2 times negative 9. It could be done by negative 3 times 6 or 3 times negative 6. This is the extent of things that multiply to give me minus 18. I need them to add to be the number in front of x, negative 7. Well, this is 17 here. 1 minus 18 is negative 17. Negative 2 plus 9 is 7. 2 minus 9 is negative 7. And you can keep going to fill in this chart, but we have exactly what it was that we needed. So we can write this as x plus 2 and x minus 9. And just like the last example, you can FOIL this out and make sure it still works. I now want to do x squared minus 7x plus 12. So I need to think of things that multiply to be my constant term, 12. Well, we know 1 times 12, 2 times 6, and 3 times 4. However, the problem is we need these to add to be negative 7, the number in front of x. These add to be 13, 8, and 7, which is close but not quite what we want. So we need to remember that this isn't really the only things that multiply to give us 12. We could also do negative 1 and negative 12, which would add to be negative 13. Negative 2 and negative 6, which adds to be negative 8. And negative 3 and negative 4, which adds to be negative 7. So now we have our solution. We'll write this as x minus 3, x minus 4. So this only happens if I want it to multiply to be a positive number but add to be a negative, in which case we really need to be considering negative numbers and how multiplying two negatives will give us still the positive that we need. I now want to look at the other case. What if that number in front of x squared is not a 1? What if it's something else? We're going to do this using the AC method, so there's a few steps that we need to do. Our first step is we're going to actually multiply our A and our C. The next step, we need to figure out what multiplies to give that value AC that we just found, but adds to give B. We can then rewrite the middle term using what we just found, those two numbers we just found. And from there, we can factor by grouping. So let's go through a few examples to see how this works. For my first example, I have 3x squared plus 17x plus 10. So I need to multiply 3 and 10. That gives me 30. So I need to think of things that multiply to be 30. Well, that would be 1 and 30, 2 and 15, or 3 and 10. And then I need them to add to be the number in front of x, 17. This is 31, 17, and 13. So I have the one that I need. And this time, instead of being able to go straight to my answer, like I could when the coefficient here was 1, I have an extra step. I'm going to rewrite this problem. I'm going to write it as 3x squared plus 2x plus 15x plus 10. So I'm going to use these two things here to rewrite 17. So I wrote 17 as 2 plus 15. And from there we factor by grouping. The first two terms have an x in common. I'm left with 3x plus 2. The next two have a 5 in common, and that leaves me with a 3x plus 2. And now they have the 3x plus 2 in common. When I remove that, I'm left with an x plus 5. So now I have my full factored form. The next one I want to look at, 4x squared minus 13x plus 10. I need to multiply my first and my last terms to get 40. So I need to know what multiplies to be 40. Well, 1 and 40, 2 and 20, 4 and 10, and 5 and 8. And then I need them to add to be minus 13. And just like before, if I have something that multiplies to be a positive and adds to be a negative, I really need to be considering negative 1 and negative 40, negative 2 and negative 20, negative 4 and negative 10, negative 5 and negative 8. These add to be negative 41, negative 22, negative 14, and negative 13, which is what I needed. So I'm going to rewrite 4x squared minus 5x minus 8x, coming from these two terms here, plus 10. These terms have an x in common. I'm left with 4x minus 5. These two have a minus 2 in common. That leaves me with 4x minus 5 as well. They now have a 4x minus 5 in common, and when I remove that, I'm left with x minus 2. So now I have the full factored form. I'll now do 6x squared plus x minus 12. So I need to multiply 6 times negative 12. When I do that, it gives me negative 72. And I need these things to add to be 1. Well, there are a lot of things that multiply to be negative 72. Negative 1 and 72, or 1 and negative 72. Negative 2 and 36, or 2 and minus 36. And I'm going to skip a few things in here to get down to negative 8 and 9, or 8 and negative 9. And you can go ahead and add in the rest of these and make sure you complete your table. When I add here, I get 71 minus 71. Here I get 34 and minus 34. And if I skip down to these last ones, I get 1 and minus 1. Well, I needed them to add to be 1, so I needed these terms. Rewriting gives me 6x squared minus 8x plus 9x from these two terms I just found in my table, minus 12. These two have a 2x in common. I'm left with 3x minus 4. These two have a 3 in common, and I'm left with 3x minus 4. They now both have a 3x minus 4 in common, and when I remove that, I'm left with 2x plus 3. And I have my full factored form.